Alright guys, we're going to talk about arrays. We're also going to save data to a file and read data from a file. And we're going to find out that doing that is almost as easy as just printing to the screen or saving data from the screen, because we can use the scanner class and we can use our print commands just like we've been doing. Now of course file IO can be a little bit more interesting than that, but to save to text files it's that easy. So let's go ahead and make a new lecture. I think we're on Lecture U. Alright, let's save to a file, right? Let's just write something to a file. Who knows what we're going to write to a file, but let's write something to a file. Hello world. So we need a file object. We also need a file name, right? Lecture U.txt, right? CIT1613 Lecture U.txt. That's going to be our file name. We don't need to keep all these out. All right. Now let's create our file object. And we're going to build it based on that file name. Now we haven't made a file, right? We've just created an object that represents what a file could be. Hasn't been opened yet. I need to add the import for java.io.file. So I'm going to come up here and do that, but I'm going to change this to java.io.asterisk so I don't have to keep adding imports for various things. Okay. Alrighty, now let's try to open the file. We want to open it for reading. No, that's silly. We're not going to open it for reading. We're going to open it for writing, right? Because we haven't got a file yet to read. So we're going to use the print writer class. Print writer just lets us print to a file as easily as we can print to a screen. You like using print line, you can use that. When you use printf, you can do that. Okay, so print writer pw equals new print writer based on that file. Now we're going to get an error here because file IO is so dangerous, so fraught with error. All sorts of things could go wrong. You could have a bad file name, right? You could have a drive that becomes disconnected, right? Your disk could run out of space. We have to do some exception handling. We've talked about exception handling in the past. Exception handling is so that we can catch errors that would otherwise crash the program. If we try to open the file and it didn't exist, then the Java runtime engine will throw an exception that we have to catch and handle. If we don't, then it would crash. Now, one cheap way to fix it, and we're not going to do it this way, is to do add throws clause. That just says, okay, this program, I don't care if you're going to get an exception. If you get a file not found exception, just go ahead and throw it. Throw it means that the Java runtime engine is just going to go, okay, yeah, you had an exception, and it's going to crash the program. Do we want that? No, so I'm going to undo that. I do not want to use that throw statement. Instead, I'm going to surround this statement with try catch. Okay, so I'm going to pad this out a little bit. And this is using something called the logger to print the error. We don't have to use the logger. We can just print our own error, right? We can just print an error saying that we could not open the file. So system.out.println error could not open file plus file name plus quote period. And then let's print the message of the exception, right? So system.out.println, the exception variable is ex, so ex dot alrighty, get message. Alright, so how can I simulate us getting an error? I wonder if I try to create a file with no file name whatsoever. if that's going to generate an error. Could not open file dot. No such file or directory. True enough, right? Okay, so that's an example of exception handling. But if we get to this line right here, we've opened our file, right? System.out.println file opened, colon, space, end quote, plus file. Let's save some data to it. I don't know what. Let's write a loop and write out 100,000 numbers to it, just for fun. For int I is equal to 0, I is less than 100,000, semicolon, I plus plus, system.out.printf, parentheses, quote, %d, because we're printing out an int, and %x, printed out as a hexadecimal number, \n, end quote, comma, I, right? Except we're not going to use system.out.printf. We're not going to print that to the screen at all. Instead, we're going to print it to our print writer. So instead of system.out.printf, it's pw.printf. And you can type pw dot and get a list of all the methods, right? Print line, right? Printf, print. I don't remember what format would do. Write a formatted string to this writer using the specified format string and arguments. If automatic flushing is enabled, calls to this method will flush the output buffer. How's that different than printf? Okay. Or you could just use dot format, right? Printf and dot format are the exact same commands. So if you want to make it look all mysterious, like you're doing something that nobody knows about, you could do that, right? That matches the string dot formats. But why not just use printf? We already know what printf does. Okay. And then maybe once every 1,000 numbers, we're going to print something to the screen. Or once every 10,000 numbers, we're going to print something to the screen. So if I modulus 10,000, is that 10 or 100, equals 0, then let's system.out.print a dot, right? Just saying that, you know, just so that we can see that some progress is being made. And after we're done with that for loop, let's print a carriage return out to the screen so that just print line will do. And now let's close our file. pw.close. Now this is going to offer me an alternate to the try resource. There's a little warning over here. It's just a suggestion. This works just fine. That's how I usually write it. But some people like the way this looks. It's called try with resource. Let's make the change. It didn't make the change. Let's make the change. Convert to try with resources. Well, I don't know why it inserted the word try again. So I'm going to copy this, undo it, and then do this. I'm just going to put this call right here inside there instead. And then I can get rid of the close. It will call close automatically on it. Oh, don't need the semicolon. There. So the try statement creates this variable, calls this function, uses it all the way through here. But if it fails to create, right, and it jumps down to the catch, then okay, fine. And if it did open it successfully and it comes down here, then when it exits the try block, it calls dot close on it. So makes it kind of clean. Maybe you like that better, or maybe you like just seeing the try statement and then seeing this on a line underneath it. Really, there's no difference, is there? Functionally, there's not. Alrighty. And so check it out. It wrote it. And it wrote 100,000 lines that long. How about 1,000,000 lines? How long would it take to do that? So that's going to be 1,000 dots. That's going to be too many dots. So let's make it every 50,000 lines we print out a dot. So modulus 50,000 equals 0. Still pretty fast. Okay, let's go find that file. Where is it stored? Well, I need to remember where my project is stored. So this is Lecture U. I'm going to right-click on the project, choose Properties, and I'm going to check the directory where it is, right? The project folder. And on a Mac, there's a real easy way to get to a project folder, except I don't think that this copy here works like it's supposed to. Oh, maybe it does. Seemed like I had some trouble with this. On the Mac, I just do Finder, go to folder, and paste that in there, but it's not going to work. Okay, so I should have looked at it more carefully. I don't know why it won't let me copy paste out of that box. That's annoying. No, anyways, it's off my desktop. I'm going to go look. And there's my file, right? It's 12 megabytes long. Real fast. That's pretty cool. And there's all my numbers in hexadecimal and in regular. So what is the number 9999999 in hex, right? F4235, whatever. Okay, so we have written to a file. How about we read from the file now? I'm going to change this so that it's only printing one number rather than two. Why am I doing that? Because I want to make it as easy as possible to read in, right? And it's easier to read in if there's one number instead of two numbers. I don't want to have to worry about parsing that hexadecimal number, although really it's not hard to parse a hexadecimal number. The integer.parseInt has the ability to parse base 16 as well as base 10, but just for the purposes of this example, I want to get rid of that. So let's just print one number. It's not letting me make changes. Why? Is the program still running? Why aren't you letting me make changes? Do I have a dialog open somewhere? Do I need to close the file? That's dumb. You can let me make changes now? Oh, for Pete's sake. Quit NetBeans. I don't see anything open that would stop me from editing. Well, I got my cursor back. Well, that was odd. Wrong lecture. That was dumb. Let me get the right lecture. CIT1613 Lecture U. That's the right lecture. All right. Alrighty, well that was annoying, but I only want to print out one number rather than two. Okay, so I'm going to take all this and put it in a function called write file, right? So why don't I just cut the whole thing? Well, I'm going to let refactor do it. This is the end of main. This is the end of the class. And I'm going to highlight everything from the beginning of main, but not counting the curly brace, right? All the way down here to the end of main, but not including the curly brace. And I'm going to choose refactor, introduce. I don't see that. Yeah, introduce method. And we're going to make a method out of that code. And this is going to be called create file. So it is now in a method called create file. It moved all of our code there. And that often works pretty good. Sometimes you have to go in and clean up what it does just a little bit when you do that, like it passes in some variables that, you know. Anyways, that worked out pretty well. Like, what if we wanted to pass this in as our file name? We'd probably want to move this back out to here. So I move the file name out there, and I want to pass it in as a parameter. I want to pass it in as an argument, so I create a parameter variable, and I need to put that there, right? And how about we make it return true or false based on whether it succeeded or not? Well, how do we know if it succeeded? If we get all the way here, it worked, right? So return true. I'm going to have to go and modify the return type. It's probably set to void right now. However, if we caught an error, we need to return false. Lastly, I'm going to scroll up here and change this from being void to Boolean. Okay. Now let's check to see if that was okay. If we have a file, Boolean okay is equal to create file. And if it worked, so if not okay, we're going to print an error message. System.out.println create file failed. Else, let's call another one called read file. And tell you what, we don't really need a million lines anymore, right? Let's just write 10 numbers to it. Because I want to display them on the screen, and I don't want to display a million different numbers on the screen. Okay, so let's write another method. Private static Boolean read underscore file. String file name. All right. So in read file, let's try to open our file. Let's create a file variable. File equals new file based on our file name. Let's open it with a scanner. Scanner SC, well, FSC for file scanner, okay? Equals new scanner, and instead of system.in, we're going to do file. Now we don't have what a scanner is yet, so let's add the import for it. Add the import for java.util.scanner. I'm going to scroll up here and just make it java.util.star. Should have done that a long time ago, right? io.star and java.util.star. And again, this is file IO, so it wants us to add exception handling. I'm not going to add a throw clause. Instead, I'm going to surround this statement with try catch. And I'm going to convert it to a try with resources. So I'm going to put parentheses here, and I'm going to move this statement, except for the semicolon, in there. And I'm going to delete this call to the logger and replace it with my own print statement, just because I think that's prettier. I like controlling what my error output looks like. System.out.println could not open file. How about an error in front of it? Plus file name. And let's print out the actual exception get message as well. System.out.println parentheses ex dot get message. Ex dot get message. Funny how if I backspace and then type the dot in again, it loads it more quickly. Alright. So what if we passed in a bad file name in main? Right? So instead of file name, I'm going to pass this in quotes, which is stupid, right? But we have no file name named that. I just want to see this fail. Testing my error handling. Have an error. Too many close braces. Oh, I'm not returning true or false, right? So if we caught an exception, we're going to return false. If we get down here, we're going to return true. So file open, file name dot. How did it open a file for reading? What's in that file? Just a second, I'm going to look something up. Alright, sure enough, it actually did make a file with that file name. And I didn't want it to. Oh, it's got those numbers in it. That's wrong, because I called that for write file, and I never called read file. Or as this says, read fi. Okay, so in main, we're going to call read file, right? Read underscore file, but I'm going to pass in a garbage file name, garbage.txt. I know that one doesn't exist. I accidentally did create one called file name. It was there when I went and looked at it, and when I double clicked on it, it was just the numbers 0 through 9 as expected. Okay, so make that say file name again as it was supposed to without the quotes. Alright, so obviously it's not going to be able to read the file. Let's run it and watch it fail, right? Could not open file garbage.txt. No such file or directory. Okay, cool. Here we're going to say OK is equal to read file because that function read file returns true or false. All right, let's get our data. It's a scanner. We can use .next or next line. It's just a series of numbers. It's called next line. While fsc dot has, or let's just call .next, it doesn't really matter, has next. While it has data to read, let's get that data. I mean, heck, we could just use nextInt, right? Trust that they are integers. So int I equals fsc.next int, right? Do you see that when I was typing nextInt, it offered the option to convert it from hex? Because you can specify the radix. You would type in 16 to convert it from hex. Or I could use integer.parseInt and specify what base I wanted it. Anyways, okay. And then let's print that out. System.out.println read %d from file. %d is actually a printf kind of thing, ain't it? So, and then \n end quote, comma, I. Semicolon. And this will close the file. We don't need to worry about closing the file because we did it as a try with resource. It's still got the wrong file name, so I need to go back and modify read file to pass in the correct file name that's contained in the file name variable. Now it should go, right? And so it's reading in our files, our data, right? And this is what it read. That's enough of an example, I think. I don't think that we need to do anything more with that. Maybe we'll combine it with arrays. All right, so let's create another method called array examples. Private static avoid array examples. Avoid? Private static void array examples. Okay, so what's an array look like? Let's make an array of ints. Int, nums, and if you've taken C++, you're used to putting these numbers over here. Well, they go here instead. And if you've done C++, no, that's not true, what I just said. This would be C++. That would be C++. I want 6 numbers. Well, it's not quite like that in Java. Instead, you have to allocate. This is a variable that is of type array. This is going to create an array reference, so you got to put the square braces after the variable name. And then you make, and you specify how long you want it. And if we printed it out, we would have 10 zeros. Let's go ahead and print it out. We're going to use the array class. System.out.println arrays dot toString parentheses nums. Not quite as clean as it is in Python, right? Where all you have to do is print parentheses nums and it would do it. But that's okay. It's not that bad. If you actually just print it out nums, it's just going to print some little hexadecimal reference. I'll show you what I mean. Let's just print out nums. Pretend we're playing with Python. That's not going to work. Oh, I didn't call array examples, so I need to go to main. And here before the end of the main method, or at the top, it doesn't really matter which place. How about here at the end? Array examples. What are you doing here? The assigned value is never used. Yeah, I could print an error message if it didn't work, right? So system.out.println parentheses quote read file work question mark space plus OK. That way it'll print true or false whether it worked. Okay, of course it's working now, so we're going to always get read file true. And then after that if statement, we're going to call array examples. And what has array examples got in it? It's got our code that creates an array of 10 integers, and it's just going to all be zeros. And there they are, right? The first print statement just prints out this little hexadecimal reference, not any use to us, so we're going to delete that line. Calling arrays.toString worked great. And I don't remember if arrays is in the java.util class or what, but if you got a warning about it when you typed it in, or an error, go ahead and add the import for it, and it's probably in java.util if it's not part of java.lang. All right, let's make some more arrays. Let's make an array of strings. So string, square brace, in square brace, names, equals new string that. And let's specify that we want 3 names in it. Well, let's print that out. I'm just going to copy this statement and paste it like this and put names in there instead, and we're going to see what we get. Well, we didn't quite get what we wanted, right? No. Well, kind of makes sense. If this array of integers is all zeros, then this is an array of string references, but strings have not been allocated yet. We'd actually have to add them in there. So we could say that name subscript 0 is equal to Abe, and that name subscript 1 is equal to Bob, and name subscript 2 is equal to Carol. Then let's print them out. I'm going to move this print statement underneath it, or just make a copy of it and paste it, right? So this printed nulls. Printed nulls. Okay, let's run it. There we see it, right? It's actually got its data now. Well, there's a shortcut for that syntax. Okay, but we can do a shortcut. Shortcut like this. String colors is equal to, and we're going to use an initializer list. Now, if you've done Python, you're used to this, right? In Python, you do this. You'd use the square braces, and you put, red and then blue in there, whatever. Well, that's Python. Same idea, though. So what colors are we to put in here? Red, end quote, comma, quote, blue, end quote, comma, quote, green. And let's print it out this way. But then let's print it out with a for loop. In fact, we're going to print it out with two different for loops. But first, we're going to use arrays to string just because that's so dang convenient. So there we go, right? We're going to see our colors. There we go, right? Red, blue, and green. Now let's print these things out with a for loop. So this is known as the for each syntax. For int I colon nums system.out.println I. Except I like to use v for value instead. I'm just going to say for every value in the nums array, print out that value. That's the for each syntax, so the range-based syntax is an alternate term for it. It's a special kind of for loop, right? It doesn't have a variable initialization, no I is equal to 0, I is less than whatever. Instead, you just give the data type of the array here. That's a temporary variable that gets filled in one by one from each element. So that's going to print out those numbers that are in our array, which are actually all zeros. Maybe we should have put some numbers in here, right? So num subscript 0 is equal to 900. Num subscript 1 is equal to 1000. Num subscript 2 is equal to 1200. Right, whatever. If it's only going to have 3 numbers in it, let's lower it to 3. Alright, so when it prints out, we're going to see it print out those numbers. This is such a small loop that I'm going to remove those braces. Alright. Another for loop to print out the colors of the names. For string value colon names system.out.println value. How about the colors? Well, we're going to print the colors out using a more old-fashioned for loop, right? The kind we're used to. We're going to print this out with an index. So for int I is equal to 0, I is less than colors.length, colors spelled correctly, dot length, semicolon I++, right? So that's an index variable. You know, we could write out the whole word if we wanted to. I don't really see what advantage that gives us, so I'm going to change that back to I. And then I'm going to print it out by subscript. System.out.println colors subscript I. And when I say subscript, I mean open brace, I, close brace. Square brace, not curly braces. And notice that it's giving us a warning here, and it's suggesting that we turn this into something else. Convert to a for loop. Well, it already is a for loop, but it's suggesting that we do it just like that, huh? Yeah, well, we're not going to do it like that. I did it like that to demonstrate printing it out by index. So let's put some little comments here. Print nums array with for each loop. Some languages actually use the word each there, like C#. Put the word each there, but no, not in this one. Print the names array with a for each loop, and then print the colors with an index for loop. So print colors array with a for index loop. Whichever syntax you like, feel free to use it. There's only one thing, though, is that you may sometimes need that index counter for other purposes than just printing it out, right? Like if you need to change the value. Suppose we were going to change the values of the colors so that instead of just saying red, it said red, red. Something dumb like that. So we could do colors I equals colors I plus, or how about the word dark, like dark red and dark green and stuff like that. So dark, end quote, plus colors I. Put a space there. And now let's print it out just using arrays.toString. We would not be able to do this if we were doing this, right? I mean, even if we expanded it out like that and we changed the value like this, whatever, you know, Fred, that's not going to work. It's not going to do a dang thing because value is a temporary variable. It doesn't modify the contents of the array at all to do that. So that was a heroic effort, but wouldn't work. I'm not going to even leave it in there. Okay, so there we go. This is going to change all the values in that array, all the elements in that array, to have the word dark in front of them. And we'll see that when we print it out. Right? So dark red, dark blue, and dark green. And we printed our array out, each array out, with 4 loops, 4 each loops, and with a 4 index loop. All right, so let's go look at the PowerPoint. Array basics. What is an array? In this particular language, there's a class called array, and when you declare an array, it's actually a type of that class. In pure C or C++, an array is just a raw data structure. It's a primitive like ints and floats are. But what is it really? It's just a list of pieces of data, right? Here's a phone list, right? And it's got some numbers stored in it, probably stored as strings, since I see some zeros in front of this thing, and you know, numbers don't normally have zeros in front of them. They're addressed by what's known as their subscript or index. The terms are just about synonymous. Some books use subscript, some books use index. This one happens to use index. So if I say x subscript I mean x square bracket I in square bracket. So the first value in the phone list has the number 0. Go away. All right, sorry about that. So the first element is 0, the second element is 1, the third element is 2, the fourth element is 3, and the fifth element is 4. Zero-based indexing. That means that if the array is 5 long, you can access elements 0 through 4. And a fancier way of saying that is that the array elements you can access index 0 through n-1, where n is the length of the array. Just remember that if it's 5, you can only get up to 4, right? Because if you start counting with your fingers using 0 rather than 1, by the time you reach 5, you've actually gotten 6. So 0 through 4, or however long the array is. If it's 100 long, you can go 0 through 99. If you want to change an element in it, you just give the array name followed by the subscript and the number. You want to access it, you want to print it out, you just print it out and you use the array name followed by a subscript. So here I had some colors defined. Right? I could have changed blue to a different color, right? Well, what's the index of blue? The index of blue is, well, that's 0, so that's 1. So I would say colors subscript 1 is equal to azure. Be fancy here. There we go. And when we were pre-appending the word dark to everything, since those colors start with a capital letter, I'm going to make dark have a capital letter in it too. What happens if we change something that's outside of it, right? This array is of length 3. How would we know that? Let's just print out the length of the array. System.out.println colors.length equals end quote plus colors.length. Like that. And it's going to say that it's 3. This is how you access it. You would think that you would need to put parentheses after it, but in this particular case, .length is a member variable. It's a property. It's not a method, so we don't put parentheses after it. And so when it ran, it's going to say that the colors dot length is 3. So what happened if we try to change color subscript 3? Well, that's 0 and that's 1 and that's 2, then color subscript 3 is past the end of the array, and we're not going to like the results. Say we want to tack on the color orange. Not going to work. It's going to blow up. Boom, exception, right? Array index out of bounds exception. And yeah, we could create a try catch for that, right? A better idea is just to not ever try to write past the end of an array. Unlike Python, you can't use negative numbers as your index values. If you remember in Python, if you've taken it, -1 is the last member of the array, the last, the index of the last member. -2 is the next of the last element, and so on. Doesn't work in this one. Negative would get you the same error as positive in this particular case. Like if I try to get a hold of -1, it's still going to crash. Array index out of bounds exception. Why don't we just delete that line or put it back in and comment it out. So this would generate an exception because as the array has 3 elements, we can only access elements 0, 1, and 2. Trying to go beyond that will give us an index out of bounds exception. So when you declare an array, you do it like that. Now I mixed the declaration of it and the creation of it. This is just a declaration of it. We don't really have an array. I can't do that and then say IDS subscript 0 equals, 32 or 13 or whatever. We don't really have an array yet. We have a variable that can hold an array. To do that, we have to do either this, where we start putting some values in, right? That'd give us room for 3 numbers. Or we can do, new int 3. Now we have room for 3 numbers. Without that, it's just a declaration. And so you give the type, and you follow that by a couple of braces, square braces, and then you give the array a name. Then when you want to create it, you use the new keyword. And so long phone list equals new long, and then inside the square braces you put however many elements you want, the size declarator. Quite often people combine this into one step, right? We could delete that there, but you don't have to, right? You could declare the variable in this step and then you can allocate it in the next. Works just as well. So it's legal to combine an array's declaration and its creation and its assignment operations all in one fell swoop, right? Just like that. So provide a single statement that declares, creates, and assigns a 100-element array that stores book titles. Well, if it's book titles, it's got to be a string, right? Where did that come from? String with a capital S. Put these things in there to indicate that it's an array, and I'm going to call it book titles or books equals new string, and I want 100 of them. Now remember, that's just 100 references. They're all set to null until we actually go in and start adding some books. Let's do that. Let's go and create an array. I just need to get rid of that, and then fill it with some empty strings. So we're gonna string books equals new string. And let's only make 4 books, not 100. If we want to be able to print it out or whatever and not see nulls, we need to fill it with empty strings. We would need to use a for loop. So for int I is equal to 0, I is less than, I could just put 4, but that's bad because what if I went and changed that? I'd have to remember to change that as well. I should always ask the array for its length. So books.length, semicolon, I++, and then books subscript I in subscript is equal to quote quote. Now we can print it out. If we tried to print it out beforehand, I'm just going to copy that and change it from arrays colors to arrays.toString books. This is what it looks like before we initialize it, right? And then I'm going to copy and paste that and put it after the for loop. I'll show what it looks like afterwards. Let me somehow group these together a little bit. I don't know. There we go. Run it. And see, the first time we have 4 nulls, and now we have 4 empty strings. Let's ask the user to enter some book titles. System.out.println. Enter the title of end quote plus books.length plus quote space books. And now let's use a for loop to let them type these values in, right? So for parentheses, oh come on, int I is equal to 0, I less than books.length, length, semicolon, I++, books, well, we have to tell them what to type in. System.out.printf, what is the title of book number, and let's put a %d there, and then a \n, and after the end quote, comma, after the end quote, comma, I. See if we squeeze this a little bit more, get it all on one page. Okay, and now let's get our book title, right? So book subscript I equals sc.next line, and I can already tell this is going to be a problem. Well, for one thing, we don't have a scanner. All right, but anyways, let's create our scanner. Scanner sc equals new scanner parentheses system.in in parentheses. Once you use next line, you're committed to pretty much using next line throughout your entire code, unless you wind up clearing the buffer or something like that. If you mix dot calls to next int and next line and dot next, it tends to behave very poorly. If you're going to use next line, you need to use it throughout your program, and then when you get a string, you're going to have to parse the data in as an integer with integer.parseInt or something like that if you need it to be something other than a string. Why am I using next line rather than dot next? Because a book can have more than one word in the title. All right, or maybe I wish I had done it like this. String s is equal to sc.nextLine, and then books subscript I equals s. Same difference. Makes absolutely no difference. All right, let's run it. All right, so what is it? Enter the title of 4 books. What is the title of book 0? I don't need that \n. Instead, I need a colon or something telling them that that's where they're supposed to type. Cancel the program. Run it again. All right, what is the title of book 0? Gone with the Wind. Gone with the Code. All right, what is the title of book 1? All right, now it started counting at 0. Does a user want to see book 0 and book 1 and book 2 and book 3. No, they really want to see books 1, 2, 3, and 4. So I'm going to come up here, and when we print out this question, enter the title of book I. I'm going to add 1 to it, just right there, just for display purposes, right? The index is still 0 through 3, but I want to display the message with, book 1. All right, and so we've asked for the numbers. We've stored them in an array. Then we could print them out. Print them out with a for each loop. For string title colon books, right? This time our temporary variable name, I'm calling it title rather than value, just because. And then system.out.println parentheses book title equals end quote plus title, right? Or if you want to print it out with an index, you can. For int I equals 0 semicolon I is less than books.length semicolon I plus plus system.out.printf parentheses book %d is %s for string \n, and we're going to fill in the index number with I plus 1, so to say 1, 2, 3, 4 rather than 0, 1, 2, 3. And then the title of the book itself is books subscript I, and then a semicolon at the end, of course. Don't need these braces. I'm going to take that brace off. Don't need that brace. Going to take that one off. These have to stay there, of course, because that block of code is more than 1 line long. I'm sure I have more than one for loop that's like that. Nope, I've been pretty consistent about leaving the braces off. All right, so let's run it, and we'll see what our for loops produce. Not that it's a big mystery. Quit the program. Run it. All right. What is the title of book number 1? Gone with the code. Errors I have known. The syntax games, and an American programmer in London. There. Those are our book titles. And we printed them out with our for loops. Here's the product of the for each loop. With a for each loop, you don't have an index. And here we have printed out with the index. Of course, it's index plus 1 so that we get nice little numbers. All right, I think that's about enough for this one. I'll record the next one tomorrow and upload it, and that'll be the one that has a homework assignment attached to it. It'll be the last homework assignment of the semester.